The difference quotient is a specialized form of the slope formula for a function f of x. It gives us the slope of a secant line to the graph of a function f of x. Recall that the secant to a function is a line that touches a graph in two or more distinct places. This is the function f of x equals x minus 2 quantity squared times x plus 1. And here's one secant line. And a secant line is going to change depending on where it's touching the function. So when we define the difference quotient and a secant line, we hold one of the points on the secant line fixed. And this is sometimes denoted a, f of a, or x, f of x. One of the points is fixed. So that's what a is in this difference quotient formula, that fixed x value. But we need another point to have a secant line. But instead of naming one fixed point, we will consider the other point by its relative distance from the point a, f of a. So its relative distance along the x-axis. That relative distance is h. Notice how h changes along the x-axis as that point moves. So as I move this one point, notice h is the distance from that fixed point. I'm not moving this point, just this other point. Notice the coordinates of this point. The x-coordinate is a plus h, right? Because I started at this fixed point and I move over to the right h units. And its y-coordinate is just f of a plus h. So the difference quotient is going to give me the slope of the secant line that's formed from that fixed point and this other point. So what is the slope of a line? It's rise over run. The run is that distance h. The rise is the difference between f of a plus h and f of a, and that is my slope. So the difference quotient takes on meaning in pre-calculus and then even more meaning in calculus as we let h approach 0. But for now, all we need to know is that the difference quotient is the slope of the secant line.